Welcome back. We're getting started on functions and graphs continued. So we're continuing this. Functions is a key point that we're going to be seeing throughout the year. So we want to make sure we're really strong on it. So this time we're looking at a piecewise function. So that's a function. So remember, a function is that every x or every y value has its own x. No x's are repeated. A function defined differently over different parts of its domain. So it's split into pieces, hence the name piecewise. So it's defined differently over different parts of its domain. And remember, domain being all of its x values. So here we have our piecewise function. And we know that this is a piecewise function because we have different pieces in different domains. These would be our domains. These are our x values right here. And this symbol here does tell us that it is a piecewise function. It's splitting up the domains for us. So now it's asking us to graph this. And so really what we're doing is we see that we have one piece of our function for everything less than or equal to x is 2. And then we have a different piece of our function between 2 and 4 and a different piece of our function that is actually greater than or equal to 4. I'm going to get some different colors out so that way we can actually see each piece in its entirety. So we're going to go ahead and start here. For everything less than or equal to 2, we're going to be at the equation x plus 1. So I'm going to start at my x-intercept of 1. My slope is 1, so I go up 1 over 1, up 1 over 1. And it does say or equal to 2, so that means I can fill in that whole of that circle. Or equal to means it can equal to. This line is just going to continue for that whole domain. My next line, I should have underlined this red, is going to be between 2 and 4. Do you see how it does not equal 2 and it does not equal 4? That means it's going to be an open circle at 2 and an open circle at 4. Well, when we get here, we would have this open circle at 2. The graph says that it's at 3. That's just y equals 3 for the whole thing. So it would be an open circle, but since it's there, it's already closed. And we're going to go all the way to 4, but we know that we end at 3. So it would be an open circle, but because they intersect, it ends up filling it in because of the blue part. And finally, we have 2x minus 5 here. So I'm using this purple color here, 2x minus 5 for everything greater than or equal to 4. So it's saying at 4, we're going to be in this function. I could go over and do my y-intercept and carry it down, but it might be easier just to plug this one in. We know we're looking at what is our graph going to be at when x is 4. We know 8 minus 5 is 3. Hey, look at that. We get to fill in our circle because that's where our graph is at 4. It's also at 3. I'm going to get one more point here. Let's figure out where we're at 5. So I could say 2 times 5 minus 5. I'm just plugging that value in for x there. So 10 minus 5 is 5. So my next one is going to be at 5, which makes sense because our slope is 2. I wouldn't have even had to do that math. I could have just gone up 2 and over 1. And so this graph is going to continue for everything greater than 4. And there is my piecewise function. So an absolute value function can also be written as a piecewise function. We talked about this a little bit already. We know that x, the absolute value of x is that everything less than or equal to 0, or greater than or equal to 0, I'm sorry, I think I said that last time too, is going to be the line y equals x. But for everything less than 0, normally our line would look like that for the graph of x, but because it's the absolute value, everything that was negative turns positive. So we actually get this v function, negative x for everything less than 0 and x for everything greater than or equal to 0. So now it's asking me to rewrite our function, our absolute value of x plus 3 as a piecewise function. So what we're doing is we're splitting it up just like we did here. So we're going to have f of x, and we're going to write our piecewise graph. We know that this graph would equal 0. That's what we need to figure out first. Because it's not at 0, where would this absolute value equal 0 at? Well, we can solve. So we know that it would equal 0 at negative 3. So that's going to be where our domains are going to be at, negative 3. So we're looking at where is this? We're looking at what's going to be greater than or equal to negative 3 and less than negative 3, just like up here. Greater than or equal to would be 0 and going forward, and then that less than part's where it would be negative, but it's going to flip up. So we have our graph of x plus 3. It's the normal graph for the positives. But on that piece where it turns negative, we actually have to put that negative sign out front because a negative makes a positive. So just like up here, the negative x, we do that with the x plus 3 as well. And so that would be our rewritten piecewise function. The next piece of information that we're going to do actually wants us to look at domain breaks. So we have two absolute value functions going on here. This one equals 0 at -2, and this one equals 0 at 1. So we know that those are our domain breaks, just like we did in the last example. So our domain breaks are at -2 and at 1 because that's where we could plug them in and it would equal 0, and we would have that shift of our function to change from negative to positive. So what we really need to think about here is before it was really simple because we knew that everything greater than or equal to, that was going to be the positives, and everything on the less than side was the negatives, right? We just had to flip it up. For this function, we have to look at, okay, we have -2. This one is going to start out as, it's going to start out as a negative function because it's on the negative side of it. Where is it less than -2? We're looking at that negative piece of it. So our whole graph here is going to be negative. -2 t plus 2 plus -t minus 1. It's just, I'm going to draw my t's like this so you can tell the difference between the plus signs. It's just like the one before, except that we just have two pieces because this is the less than side, right? It's that smaller portion of our graph where we're in the negatives. I'm going to go ahead and jump down and then we can go back and simplify. This one is weird because it's in the middle. And so what ends up happening is because we're in the middle here, we have this -2. We're past that now. So that means that this portion is in the positive portion of our graph. And maybe it would help us to actually look at our calculator and to be able to look at this so that you have an idea. Because it's a little bit hard to visualize at first. So if you don't know how to graph your absolute value function, you should be able to go to math. And then you go to complex, and then you go to absolute value. So there we go. So we say x plus 2, because x and t would be the same thing in the graphing calculator. Then we can go to math, and then we go over here, go down to our absolute value function, and then we would go to x minus 1. So my zoom is super funky. I need to take that back to zoom standard. I think I passed it. Here we go. So see, we have that change right there at -2, and then we have that change right there at 1. So we know that this was going to be negative values that it flipped up. And then in between, we've passed that negative portion, so that means that past -2, that -2 part is in the positive, but the -1 has not passed it yet. So that means that this t plus 2 can turn to positive. However, the t minus 1 has to stay negative. But then for everything greater than or equal to 1, that means that we've passed them both. So they both can become positive. And then now these are just things that you can combine like terms. So we have 2t plus 1. And then here we can combine our t's. We have t minus t, so our t's actually go away. Then we have 2 minus minus 1, which makes 3. Then we have -t minus t is -2. -2 minus minus 1 would give us -1. And so now we have our different portions, so we can actually split it up. So we have -2t minus 1, we have 3, and we have 2t plus 1 for our piecewise function. Let me draw that just to make sure we don't get mixed up. So this is for everything less than -2. This is for everything between -2 and 1. And this is for everything greater than or equal to 1, just like we did above. And now we have our piecewise function for our mixed one there. So what about when we get into combining functions? Once we're reaching our combining functions here, we're looking at what happens when we actually add them together. So it literally just means we have f is x squared minus 3, and we're adding it to g. We say plus 3x minus 2. And so I can just combine like terms here. So I have x squared plus 3x, and then I'm combining negative 3 minus 2 is negative 5. So as you can see, if I'm combining the domain, a domain combination, when I'm adding them, it's the intersection of the individual domains. Because the domain of x squared minus 3 was all real numbers, the domain of 3x minus 2 was all real numbers. So since they both were, when I add them together, they're all real numbers. So you can kind of figure out the domains of things when you're adding by looking at the individual pieces. Next, we're going to look at division. So f, our function was x squared minus 3, and then our function for g was 3x minus 2. So f was x squared minus 3 over 3x minus 2. That was a really bad minus sign. Sorry, guys. Okay, so now it's just saying, can you look at your domain? This domain will not carry over because now we have something in our denominator. We can't have our denominator equal to 0. So that means 3x minus 2 cannot be 0. So we have to solve and figure out where x can't be. So we get 3x cannot be 2. We divide by 3. And x cannot be 2 over 3. So that domain is a little bit different. So be careful if you're looking at domain. It doesn't carry over for division like it would for addition. This is just a way that you can actually graph it on the calculator. You can do those ways. I think that it's personally easier if we were trying to graph the problem that we just did to just say x squared minus 3 in parentheses, and then you can actually go back and you can divide 3x minus 2. And then you can graph one that actually has the division there for you. Or you can follow these steps here on the note if you want to make it into different functions too. It's up to you. I think personally this way is easier. Okay, function composition. We're looking at f of x and g of x. So this should just be a little bit of review here. We're saying we take that inside piece and we put it in first. So we're taking that x squared and we're putting it inside. So we have f parentheses, and g of x is the same thing as x squared. So we put x squared in. And then what we're doing is we're taking whatever f is, we're leaving the space for x, and we're plugging in whatever g was. So you're just taking this value of g and you're plugging it in for x. If we strike and flip that, you go the opposite way. We're taking g, but we're plugging in f of x, which is x minus 7, in place for g. So we're taking this x minus 7 and we're plugging it in for x, which is going to give us, we have that blank for the squared, and we're just filling in the value for x minus 7 squared. That's our composition of function. So now if we're looking at drawing a complete graph of something, this is again something that we can pull up on our graphing calculator. So we could go into math. Where do we go? There we go. We go into math, go to complex, go down to the absolute value function. I think I hit the wrong button. Sorry, guys. I was looking at my video to make sure you saw it. Hit enter. There we go. So then now we say x minus 1, and then we divide by parentheses x minus 1. We should be able to graph that. So we can see something funky going on here because we have that break, because it can't equal 1, because that would give us a gap in our function. So see how there's actually that hole at 1. It doesn't actually equal anything at 1 because we have x minus 1 over x minus 1 there. All right, we're almost there, guys. Okay, so draw a complete graph and then compute the functions there. So it's just asking us to do our piecewise function. And I'm just going to start this part because I think that you can do it. It's very similar to the one that we did, but I just want to give you a heads up to get started. You know that you're going to start at x is less than 0. So you're starting at 0. This first function of x squared has to be less than 0. So this portion has to fall under x squared. Our next portion, x cubed, is between 0 and 1. So that's x cubed. And then our next portion for everything greater than 1 is going to fall under 2x minus 1. And then now from there on out, you can just plug in a few points. If it's not linear, you want to plug in at least 3 points to make sure you can see that curve to go. So you can plug in those pieces there. So for here, you could plug in anything negative. For here, you could plug anything between 0 and 1. And then for here, you could plug everything greater than 1 and be able to have that graph. And then now here, we're just looking at these x values, and you can plug those in to the correct portion. So let's do this part because that is a little bit different. You can look at the graph to solve it, but you can also do it algebraically. F of negative 1 would fall under this portion because that is where the domain is less than 0. So I would say negative 1 squared because I'm plugging it in for x squared. So negative 1 squared is just 1. For 0, this one's trying to trick you because this one says less than 0, but this one says less than or equal to. So it actually equals 0 at 0. So we're plugging it in for x cubed there. So for this one, you would plug in 0 for x cubed. I'm going to leave this one here for you to do. Please write down in the bottom any questions that you have on the assignment, and I'd be happy to help you tomorrow. But please jot down those questions so I can help you. Thanks so much.